In section 6.4, this section covers adding and subtracting rational expressions. We have covered that already with some of the previous videos that you viewed. However, one thing that was not included were complex fractions. Complex fractions are fractions that have a complex fraction is a fraction that has another fraction either in the numerator or in the denominator or both. Okay? To simplify this type of situation, really, if you've got just one fraction in the top and one fraction in the bottom, let's look at that real quick before we do this one. I'll come back to this in a second. But let's say if you just had one fraction in the top, so maybe you've got 1 over 3, and then in the denominator you've got 3 over 2. So 1/3 divided by 3 halves, okay? In this situation, all you have to do is to remember that the fraction bar means division. So you're doing 1/3 divided by 3 halves, and you should know that dividing a fraction means you're going to multiply by the reciprocal. So 1/3 times 2/3. And then you would multiply that together to give you an answer of 2/9. So if you just got one fraction in the top, one fraction in the bottom, you can use this approach if you want to. That keeps it pretty simple. However, in this example that I'm given here, I've got 2 fractions in the denominator. So I'm going to take a slightly different approach to get this to where I can handle it a little more easily. And the idea of problems like this is to first look at each of these denominators. So you've got an x plus 4, and an x. We want to find the LCD of all of those fractions, or the least common multiple of all of those fractions, okay? So I'm going to go onto another page so I can start fresh. So I've got 5 over x plus 4 all over 1 over x plus 4 plus 2 over x. Okay. So if I look at each of these denominators, x plus 4, x plus 4x, I need the least common multiple or the least common denominator of each of those. My LCD, just like we did when we worked with the rational expressions earlier, if you can factor in any of these denominators, you need to. However, x plus 4 does not factor. And then x, there's nothing I can do with that. So if they don't factor, you just take each one and put it into your LCD. So my LCD needs to have x. It needs to have x plus 4. And up here I have x plus 4 again, but I already have that, so there's no need to put it in a second time in the LCD. Okay? Now that I've determined the LCD, I'm going to multiply both the top and the bottom fractions by my LCD. Okay, so we want to multiply. Now, we're going to multiply the top and the bottom by the LCD, but then we're going to distribute. So you can actually kind of shortcut this and say that you're going to multiply each individual fraction by the LCD. Okay, so that means, I wish I had another color, but I don't think I do. So you're going to say 5 over x plus 4 times the LCD. So that's what the top looks like. And you can put that over 1. In your denominator, you've got 1 over x plus 4. Multiply that by the LCD. You can put that over 1. And then you've got plus 2 over x times the LCD. And you can write that over 1. Okay, so you're going to multiply each fraction by your LCD. Now, how does that help me? Well, if you go back, look at the numerator now. If you can find any common factors, you get to reduce. So x plus 4 goes into itself one time, so that cancels. So you're just left with 5x over 1. This process of multiplying each fraction by the LCD actually eliminates the many fractions on the inside. So you're left with whole numbers. So your entire numerator is just 5x. In the denominator, if I multiply these together, x plus 4 goes into itself once, so that leaves me with 1x over 1, so just x. And then over here, x goes into itself once, and I'm left with 2 times x plus 4. Okay, so that was the hard part. The rest of it should not be too bad. All that's left to do now is to simplify this denominator. We can distribute and combine like terms. So we have 5x over x plus, that's going to be 2x plus 8. We can simplify that. I'm going to caution you against something as you're doing this. I do not recommend, and you'll notice I'm going vertically on my paper, don't put equal signs and move to the right. The reason for that is the next topic is going to be rational equations, and they have a different approach than these expressions have. So in other words, if the original problem has an equal sign in it, you're going to handle it differently than you will if you have an expression with no equal sign. So if you start putting equal signs in here, it's going to really mess it up and make it more confusing for you. But if you want to move left or right, instead of an equal sign, maybe just use an arrow to indicate that's your next step. So over here, in my denominator, I see I can combine these like terms. So that gives me 5x over 3x plus 8. Okay, and the only thing I can do now is see if anything will factor. 3x plus 8 does not factor, so I cannot do anything else. I cannot cross out the 5x and the 3x because of that plus sitting there. So my answer is 5x over 3x plus 8. And we'll do another example together. So example 2, I'm going to do x over 6 minus x over 3. If you're interested, this is coming from the monitoring progress on page 335 of your textbook. This is actually number 10. X over 6 minus x over 3 divided by x over 5 minus 7 over 10. Okay, so just like we did before, our first step is to look at each of these denominators and find the LCD. So we've got a 6 and a 3, a 5 and a 10. So 6 and 3 has a common multiple of 6. Okay, so your LCD needs to have a 6. And then the denominator here, a 5 and a 10, has a common multiple or common denominator of 10. So 6 times 10. All right. You can multiply this together and say that your common denominator is 60, but that would not be the least common denominator. Your least common denominator would actually be 30, because that's the least common multiple of all of those original numbers, 6, 3, 5, 10. Now, let me take just a second to explain another way to look at this. In order to find the LCD, it's helpful if you think about the prime factorizations of each of these numbers. So because 6, so let's just look at the original factors. 6 is 2 times 3. So I've got 2 times 3, and then I've got a 3, and then down here I've got a 5, and 10, the prime factorization is 2 times 5. So remember, when you get your common denominator, you need to have every factor, okay? So your LCD needs to have a 2, needs to have a 3, okay? I've already got 3, so I don't need it again. I need a 5. There's another 2, but I already have it, and there's another 5 that I already have. So these are all the factors that I found these are all the factors that I found from each of these denominators. So that gives me an LCD of 30. Okay, now if you did 60, it's not wrong, but you're going to have more stuff that you have to simplify if you don't use the least common denominator. Okay, so now that I've got my common denominator of 30, multiply the top and the bottom of the original fraction. I'm going to rewrite this so it's not all jumbled up so bad. So I'm going to multiply my numerator by 30 and my denominator by 30. And then I have to distribute to each of the fractions. So you can really shortcut this and just say that you're going to multiply each fraction by 30. So again, multiply each fraction by the LCD. So we'll have x over 6 times 30 minus x over 3 times 30 over x over 5 times 30 minus 7 over 10 times 30. And then each of these can be simplified. 6 goes into 35 times, so that gives me 5x. Over here, 3 goes into 30 10 times, so that gives me 10x. No more fractions in the numerator now. Denominator, 5 goes into 36 times, so I've got 6x. And then 10 goes into 33 times, so that gives me 7 times 3, 21. Did that have an x on it? No, it did not. Okay. Okay, so what can I do now? In the numerator, 5x minus 10x, that simplifies and gives me negative 5x over 6x minus 21. Again, don't cross these out because you've got this minus. Is there any, I don't see anything that can be, I can factor the denominator. It does have a common factor of 3, so I could say it's negative 5x, and then pull out the 3, it leaves me with 2x minus 7, but I don't have anything that I can reduce. So final answer, either one of these is perfectly acceptable. So it was negative 5x over 6x minus 21. Okay, so I'm going to stop here. The assignment that you'll be doing for this section will be textbook page 337, problems 39 through 44. So this will cover anything that was not included in the previous set of videos that you watched on rational expressions. And that's it for this section.